Hello everyone, welcome to my YouTube channel, Precision Manufacturing System. We come back with another interesting video, and this time we are going to talk about simulation, additive manufacturing simulation. And in this tutorial, I'm going to talk about how we can do the single layer additive manufacturing simulation and what parameter and factors we need to consider in our simulation. I would appreciate it if you could subscribe on my YouTube channel and hit the like button and stick around with the end of this video. And one of the interesting things of this tutorial is that we don't use subroutine, DFLUX subroutine, or any kind of subroutine in this simulation. Please be with us until end of this video and see how we can implement this simulation. Without wasting the time, let's start and do the simulation. First, we need to design the actually our substrate. And let's put 0.1 and deformable 3D solid. I wanna model my substrate at the origin, so for that's why I will fix the origin and then create the rectangle. This is correct, and this would be 0.5. So, and this would be 0.8. Okay, and then next we need to create a layer, and for the layer we need to revolution and 0.5. So again, I wanna let's do like this one. Just put here and measure from here. This would be 0.1 and this would be 0.002. okay, and this would be okay. This is our layer that we want to print on our substrate, and then we need to make a partition on our layer. So let's do that, and for that's why we need to do some datum, and let's have a partition cell, use datum defined, and that's another. And actually I wanna divide my layer into 8 pieces. So now we have 4 pieces and we need 4 pieces more, and for that's why we are going to create more datum and then create a partition. So this is, and then finally this one. Okay, now we have 8 pieces, and each piece will be going to print it on our substrate. Okay, let's continue. Then property, we need to define property, time dependent property, and this would be steel or our substrate, and the material property of substrate is this, and I would like to copy this 7820 and thermal conductivity. Note that you should check this option to have a temperature column here and then paste it, and for a specific read as well we need to define temperature and paste it here. Okay, then we have layer, and we have to do the same procedure and same method for the layer, density, conductivity, and a specific heat based on the temperature. So let's define the density and conductivity. 8110 conductivity, paste, and copy the specific heat for layer and paste it here. Okay, we did it for material property, and let's create the section still solid homogeneous, and for steel, and for layer we need to define another, sorry for my writing, and layer, and then assign the material property to the layer, and substrate, assign it. Okay, then assembly. Let's first create the substrate. I put the substrate at the origin. Okay, and then sorry, layer, let's put the layer at the center of our substrate. So for that's why we need to measure from here. We need to move in a z direction by this amount, and for the x direction by this amount. So we are going to move this layer in x direction by this amount and by z, and just put any number for y direction to move in y, and then we are going to put it on the surface of our substrate. Okay, this is now in the middle of our substrate. Then we are going to put it in the actually move to touch or place it on exactly on top of our substrate. Our movable part is this one, and our fixed part is this, and the axis is y-axis, and the direction should be like this one. Okay, now it's okay and everything is done. You can see it's located at the center of our substrate. Okay, then let's mesh the part for our substrate. Put 0.002 to have at least 3 or 4 element in the thickness direction, and this is structure. Okay, since our simulation are heat transfer simulation, we need to put it at the heat transfer and reduce integration. Okay, and mesh and layer. I think this size is fine, and okay, this is okay, and just put in heat transfer and check the reduce integration, and then okay, everything is done. And let's create the set for each layer. For that's why we need to put it on cell, and by first manager, clicking each cell, and we need to create set for each piece. Then later we want to use this set for printing our layer. Okay, you should do that for 8 pieces as we defined at the beginning of our tutorial. And then again this part, element, select all, the fixed pieces, and here okay, and the last part should be like this. Sorry. Okay, and one more set should be defined as a whole layer, and we should choose whole parts as a whole layer. Okay, done. And then let's define the model attributes, and this one absolute 0 and second boson. This is 270, sorry, minus 270. That point. Let me find that number, and this is 5.67 minus 8. Okay, done. And the next part, we should define the steps, and in a step we need to first define a breadth and depth step. For the first step, breadth and depth and heat transfer, this would be actually 0.1, and here this would be 0.1, and this is minus 20, this is 350, and this would be 1 million. Okay, and we need to define 8 more, actually 9 more steps, including cooling, and eight steps for printing, because we have 8 pieces. So let's do the define the 8 steps for each pieces for actually printing each layer, each section or each segment. And E minus 20 and 2.5. You have to define exactly same for all of them, and five second for each step, 1 million, 0.01, 1 E minus 20, and 2.5, 350, again 5, sorry. I will pause the video, and then once I create the order, I will play and record the rest of the tutorial. Okay, I have to find actually 8 steps for printing, and the last step would be cooling the step, or let's name it cooling. And for this, for the cooling, we need 420, and this will again 0.01, 1 E minus 20, and this would be half of the step, and again this one's 350. Okay, the steps actually were defined. We have one step for breath and death, and for activation and deactivation, and 8 steps for, as you can see, it is exactly the same with the first step, like this one, for printing each set or segment, and then last step would be the cooling step. Okay, let's continue the simulation, and we need to define some heat losses for our specimen in interaction module. Since we have heat transfer, we need to define these heat transfer here, and for that's why first we need to define the model change in burst steps, burst and death step, and put element deactivated and select the layer. Okay, and then we need to define for 8 segments, but for the segments we need to put on reactivated in this step and select each set. Okay, step 3, and again the same for until 8 pieces. Okay, for the last pieces, step 9, and the activated element, and step 8. Okay, we have defined 8 model change for each section, and then we need to define the surface film condition for substrate and for the layers. Since we have heat transfer and heat losses in our simulation, we have to model this behavior of the simulation in our simulation, actually the real-time process in our simulation. So film substrate, I want to select the substrate and put 10 here, film condition and coefficient and skin temperature 25, but note that we should deselect the button. Sorry. Again. So film substrate. Select this one and deselect the bottom surface. Okay, 10 and 25. Okay, and for the layer we need to use whole part of the layer for this option. Serve film layer. Actually, I made a mistake here. We should put on burst and death step for both here, and 242 and 25. Okay, let me, yeah, for this one we have to make it here. Okay, and the last one, we need to define surface radiation on the first death step. Surface radiation, and we need all model and click all, but we don't need the actually bottom surface of the substrate, and here 0.7 and 20. Okay, the interaction was completely done, and the last stage we need to define the energy or the source of the energy actually for printing, and it depends on the method. Additive manufacturing, it is it could be different, but actually the amount of the heat can be different. But here generally it could be defined by surface heat flux, and we don't use any subroutine or any codes. We just use the nature of the ABAQUS equations and the method, and we use uniform distribution for actually distributing the energy on the for printing, and just select the layer and put it here to have a good control on your model. So let's do it again. Create on step 2 surface heat flux, and for the first segment select OK, use distribution, uniform distribution, and just the amount of our source for energy. Okay, but you should know that you should deactivate it in the next step, and again create for the next layer segment in the next step, exactly like this. And 1.24 3E7, and again deactivated, copy, and step 4 delete this one, 1.24 E7, again deactivated. We have to define all for all segments exactly like this. Okay, let's create for the last segment, last piece. Okay, and then deactivate it. As you can see, we have 8 pieces, and for each pieces we defined one source for one printed source, and again here we need to define the predefined temperature, initial temperature. Here we need to define 25. Okay, all the steps were defined, and finally we need to run our simulation. Single and egg process, okay, and then submit. Yes. Okay, as you can see, the simulation successfully done, and it is running. I will pause the video, and once the simulation completed, I will come back and visualize the result to you guys. Okay, the simulation was successfully done, and as you can see, it is completed, and we can see the result, and This is the result of our simulation. And each segment is printed respectively and as we defined in our simulation. Thank you for watching this video and being with me until end of this tutorial. Please let me know if you have any difficulties for your simulation, or if you have any suggestion for our channel. Please let me know and send me an email, or write some comments in below of this video. And thank you for you guys, and please don't forget to subscribe to my channel and being a strong motivation for our group. Thank you so much. Bye. See you.